right there at the top. There's also another hint. Now, why is this important? Because we're going to do propulsion systems. You have to start it like this way. We're not doing perpetual flows. We're not doing high-speed aero. High-speed aero is a tool for us. But we have to do this for propulsion systems. So this is very, very critical for sports. If we can't do this, we struggle with the engine overall. We're trying to do this balance overall. But the ramjet that we're going to start with and turbojet engines are always starting with the questions like this. The last problem was primarily your reactions. I've given you some fuel of some sort. I'm telling you, just computer, X stoichiometric. So I'm not even giving you any tricks, and I'm giving you all the tables and information there. This is the same stuff that you have in the homework. Who did not expect this problem to be in there? I told you this problem was going to be in there, right? So this, I'm a bit disappointed that it wasn't 100% everybody got it, right? Everybody should have got this one. You agree or you don't agree?
We agree. Agree to disagree. Let's move on, man. Come on.
All right, so this one is straightforward. And that's a substantial amount of the grade, right? It's 30 points out of 100. It's 1/3 of the grade alone by itself. The true false and the first question are actually very easy. They're 20 points for 20 points. In reality, 70 points of that exam is in your pocket already through those. Now, problem number 2, again, it's not that challenging. But at least with some of the credits that are given in some of these equations that you list, you should be able to get at least 60 to 70% of that. You'll be into 80% total by just doing this exam and not even having enough background or. And this is actually all review too. This is not propulsion systems. This is all thermodynamics, high-speed aero, and your fluids course. That's it. Nothing to do with propulsion yet. So in reality, this exam is just a review. However, as I said, I think everybody's done pretty well. Could have been a little bit better, but overall, I think people have done very well. We'll don't worry about the grade overall because I think last year, the first exam, the same scenario. The second exam, which was on propulsion systems, people done very well on the second exam than the first exam. So I think it's the first exam that reviews all your material in the past. So it covers, as I said, thermodynamics, fluids, high-speed aero. So it's covers quite a bit of material, and from there, since it's not a cumulative like exams, people do better, I guess, in propulsion. So, okay. Any questions on this? We're good? Should we move on from this topic? Yeah. Okay. All right. Just had spring break and forgot about it, and you reminded us. Okay. So the project, I'm going to post it today. Let's just briefly talk about it. The information is on there. It's essentially a hypersonic advanced propulsion system technology that we're working on in the lab for the Air Force. Essentially, what we have is we want to be able to do hypersonic combustion at a Mach 5 flow regime. So, to do this, we have to have a Mach 5 hypersonic flow and add our fuel and burn. So currently, actually, your TA is the one who's working on this as research. He's designing it, and he's working on actually fabricating it. So he's doing a cheat job on fabricating it and things like that. So hopefully, he gets it done by the end of the semester, so you'll see it run. But it's simply a multiple high-pressure tanks, because we're looking at Mach 5. If you do the calculations for it, you'll realize how much pressure you really need. You need a significant amount of pressure. So there's high pressure tanks that are in series, plumbed in together into a diffuser-like shape, then into a straight channel, and into a CD nozzle where I'm giving you a cross-sectional area where primarily that's your propulsion system, right downstream of that CD nozzle. So the expectation is I want a Mach 5 condition right here at the inlet, and I want to design the CD nozzle. So it's essentially, you can think of it as your high-speed aero type of problem that you've done. Now, the thing is, we need to hold a normal shock at the end of this. And we have a friction coefficient that is given to you here in the CD nozzle, so you can figure out how to actually get your shock at the end of the test section. We kind of did a very similar example in the class. So I'm giving you some dimensions right there. You can figure out the dimension of the CD nozzle. What is the stagnation pressure right here to stabilize a normal shock at the very end right there? And then I ask you for how many tanks do you really need to run this for 5 minutes? And it gives you an appreciation of the amount of flow that you need to run such a hypersonic propulsion system like this. And then I ask you again to determine the heat release through combustion, which is primarily you have hydrogen and you have air, and you're burning a stoichiometric condition, you're determining the heat release. So it's a very, very nice problem that couples in some of the review process that we went through with reacting mixtures, high-speed aero, and all the conservation equations that we went through so far. I'll give you about 2 weeks to solve this. It's pretty straightforward.
That's not 2 weeks.
Sorry? Yeah, I'm gonna adjust the date. The idea was to give it to you before spring break, but then I realized nobody's really gonna work on that. So I was like, let's just do it afterwards. So this was from there. So I need to adjust it. But anyway, think of it as a glorified homework problem, really. There's nothing to it. You can almost compute it with a calculator, do it in Excel if you wanted to. You don't even need MATLAB for this.
We can do it by hand.
So, any questions on it? Questions? No. I'm not writing a report and all that. So don't worry about the report.
Is this like a small group thing or just individual?
So I struggle with this because, so here's what happened. I tried to do, and you tell me how to tackle it. You guys are as experts now, been within 4 years or 5 years at UCF. So last year I had a project, right? And I had different tasks for different groups. I'm fine with people working in groups. Yes. But how do I distinguish the individual effort versus the group effort? Meaning that if one of your colleagues, was not working with a group, right? So how do you give him credit that he worked on it on his own?
Do you include a peer evaluation?
You guys.
Are you talking about? Are you just like a certain blank slate of paper and you just say like everyone work together to check, or nah, this guy sucks? Check.
If they were that bad, it's the group's responsibility to say something to you.
Sorry?
I said if a group member is that terrible, it's that group's responsibility to tell you.
I'll tell on people.
Well, I'm thinking from the person that's going to work on the project on their own.
Oh, individual compared to project, group
Yeah.
to a group. Find some friends. Like, I mean,
No.
like, why would you work on it individually if you can have a group?
What's the issue with that?
I'm doing a group anyway.
So what I did last time, I had one project, and I had 3 questions.
Okay.
If you're working individually, you will do one of the questions. If you're working in a group of 2, you do 1 and 2. And if you're working on a group of 3 or to 5, you would do 1, 2, and 3. So what happened was, everybody worked together still, and they submitted problems, the first problem only. Yeah, you guys are smart. So I couldn't do any better in terms of, so I still got almost 100 submissions, which didn't make any sense to me. So I'm trying to figure out a way to be fair to everybody, and I don't know how to do that. But then they're going to be working together anyway. So how do you distinguish it?
It's just working
And
groups.
anything, sometimes when people work together,
Why do you want to work
it helps understand some
What
of
do
the
you think?
process, right? So, and this is a project. This is not a exam. And the project is actually worth 10% of your grade. So this is a substantial amount. And it's straightforward. So if you're thinking about tests, tests are nothing compared to this. This should be 100%, should be getting this. It is easy, right? How many of you think this is hard? Please raise your hand. That's okay. Don't be shy. That's okay. Okay. Now, probably because you haven't really sat down and read through it. I just babbled about it and things like that, so it seems scary, and I'm saying hypersonic and so forth. So something that will scare you off. But in reality, when you realize it's just a problem from homework number 5 that you just did, really. And I'm going to give you an example of seating now. Question.
That's the last problem.
Yeah, so no friction at the seating nozzle. This you don't even have to worry about. You're not doing anything here. You're only figuring out what is the initial pressure here. And the tanks, I'm going to give you the volume of the tanks and the pressure within the tanks, and you're just determining mass flow rate, which is problem 1B in the picture. It's going to be final answers. So, final answers. And they're going to be graded immediately just to show primarily your work. So, list the equations and the final answers.
You don't care what we use to solve it, like what program or method. Okay.
But just show your equations. How do you think about it and all that? The reason I'm saying show your equations is because so you get credit. What if you didn't get the right answer? Right? So, as you've seen from the midterm, what helps you is actually the fact that you're writing equations, not the final answers. Okay, so write the equations, the process, the steps. So if you did it in a code, just write down the equation steps of how you did the code in terms of the equations itself, and the final answers. Yes, please.
If we were doing like MATLAB, would you want us to turn in the code as well, or?
No.
Okay.
I think this is solvable in
just
one single piece of paper. Really, you don't really need much for this. Now,
Send something.
the ramjet one might
Something.
need a MATLAB, but I'm trying to actually minimize it so you don't need MATLAB. But they didn't need MATLAB. You did it in Excel. You can do it in Excel as well.
Oh, no, I did.
Any questions on this?
You made me silent. Silent.
So, should we take a vote of what should we do, group versus individual?
Oh, so you got out when you gets you out. It doesn't get me out. What do you read it?
Why don't you just choose and
Weird
move
things
forward?
that we send in the group that best knowledge.
Either or, I don't give a shit. Like, let's just move forward.
So individually?
I love you.
Is that the majority? Everybody sent individually? Yeah. All right. So individually, please.
Oh my God.
Oh man, he's so fat.
Okay. So I'll give you 2 weeks for that. It's straightforward, but take it as an opportunity. This is a good chance for you to practice the equations without.
That's what you get if you don't need help.
Like for the midterms itself, when you just start the midterm, obviously the grade distribution, I know it doesn't reflect what you know, because first is you're waking up early in the morning, right? It's not the ideal time. Believe me, I understand. So that's one. Second is there might be a little bit of anxiety because of the timing and all that, so you're not thinking clearly. So try to leverage the projects for doing and trying to understand the process better. Does that make sense? Ideally for me, I would like to do the whole semester projects, but UCF policy requires you to do exams. So it's not my policy. Okay?
Makes everybody happy.
I see that,
Everybody happy.
you know, just based on the schedule, we're a little bit behind. And I was curious, do you still plan on holding a second midterm before the final?
Yes.
Okay.
So that's a good question. So where are we at?
Way
Now,
behind.
as I mentioned before, we spend quite a bit of time in the review process. And it's not surprising because we go over a lot of material. I could jump into propulsion directly, but you're going to be lost. Today we might start some of the propulsion aspects. Within the next 2 weeks, we're going to cover ramjets. And right after it, within a week or so, we'll cover turbojets. And then you're ready actually for your next midterm. And that's another thing. I'm not giving you homework this week to start working on the project, so it worked out better. No cheering there. Okay. So we had the second midterm somewhere around there. Ideally, the second midterm is going to come somewhere here, the first week of April, and maybe the last week of March, but somewhere around that range.
That's what we
That's 2
learned.
weeks. So plan on that.
Good job, guys.
I'm going to solicit the timing beginning maybe on Thursday. Let me think about the timing, when we're going to cover, and make sure that we cover turbojets.
Now, you
And
wanna
the
go
first
faster?
midterm is going to be, or the next midterm is going to be on ramjets, turbojets, and turbojets with afterburner. We're going to cover those. So don't worry about it right now. It sounds freaky, but,
What? You have to buy it.
okay?
You will buy it.
Any questions?
But I will soon.
We're good?
It's still out. And the last time I
So,
checked, a week ago, they were
Given that you
negative.
have to work a CD nozzle like this, and you have to put a shock right here at the exit, and you want to make sure that this is a Mach 5 flow, right? So I want to do a quick example problem that will help you in trying to determine this.
Make sure you
Okay?
Make sure you don't call it.
Which is just a recap of your high-speed aero again.